Hello. It is time. That is just so quiet. Why? Okay. I just looked. I need to do constraints. Constraints. Also, it once again thinks, I don't know what it is about this. It's got to be like the comment sitting here at the bottom of this function makes it think this function is just the rest of the file. Because it was just like 167 and then 700 or whatever this. Jeez. What do I do about that? Is the last in pause even used anywhere? What is this? How long has that been there? I mean, I think really I just need like, I don't even know, like a line down here or something. In the update method. Or maybe I just need to remove the comment. Like, I wonder if this trips it. I wonder if this line, this trips it. It gets here, it sees the comments like, oh yeah, whatever. And then it says, oh, we're making a new block. And then it makes a new block. And that block lasts the rest of the file. Who knows? It's annoying. Constraints. What exactly was I doing? Right. I think I've said that I just, well, maybe I should try to understand exactly what this is doing. Nope. I'll try that. I feel like something's going on here. There's something happening. I'm gonna try to like reset this playlist or something. I think it's stuck on a specific shuffle right now. Is that okay? Because I feel like that song is played every time, the last few times. Well, I mean, I don't know. I guess what I mean is like there's a specific order. I think the shuffle isn't resetting. Or I'm just crazy. That's also possible. It could also just not even be shuffling the whole thing. It could be like picking 20 songs, playing that, and then picking another 20 once I run out. Okay, so clamp, swing, twist. So if twist is free, in, out, twist is this thing. Delta min is greater than 0. I guess it means that it's present. Let's just assume that's the only thing that happens. Then it says inverse initial orientation. It says part, this part. Solve position constraint. guess the way that I read this is that somehow in constraint rotation, get x. Twist half max angle. This is computed here. Calculate constraint properties. Not this one. Does this not run calculate? What I'm thinking this should be doing is setup, calculate constraint properties. Constraint rotation, constraint to world. Rotates from body 1's constraint space to world space. Okay. So I take some rotation on body 1, I transform it by this, and I get a world rotation. Yeah, okay. Because what I'm thinking this must be doing is that it must be essentially saying, hey, here's where it is right now, and it saves that in some way, which would calculate I'm looking for twist. The way that I think this is working is that it basically computes it in such a way that everything lines up so that when I say, all right, here's where we are right now. Ultimately, what has to happen is that this obviously needs to come out to be 0 when this is not exceeding any limitation, which means this orientation is what? If I run it in order, body to rotation, I transform this by this, and then I transform that by the opposite of this. I'm not exactly sure. And now that I'm looking more closely at it, I am missing a lot of things too. I haven't noticed this. Twist limit constraint, swing limit constraint. I mean, I actually shouldn't really need that because we're creating a different one and using that. But I think I did miss this. Ooh, no. Not that. What did I miss? I missed this. This is in the setup, so I can just do that. Rotation should just be body 2. Yeah, cool. So it'd be constraint body 2 to world. Which I'm not sure where that's computed. Oh, there it is. It's right there. Though I do think I can probably still ignore quite a bit of this actually, because this one's mainly responsible for calculating. Actually, this one won't do anything really. Because none of these values are used. Wait, so where is that calculated? Clamp, swing, twist. Because it's these values. These values need to... They're in the set limits, of course. Okay. Let me try to understand this. Half twist, twist min max is X, swing Y, Y and Z just X, or Y and Z. So if I'm on X, that means I would use this twist angle. If I'm on Z, I use the Z angle. Y, I use the Y angle. And then twist S, twist C are just the sine and the cosine of each of these individual, oh well, half the sine cosine. Okay, so this means we're locked. Okay, I think I might just need to split this or something and just read through this one. So I say delta min and delta max. IO twist is my twist thing, which I have. I've done the negate. Alright, I'll just start writing it, I guess. Also just copy it. Did I miss the last? What? That is just weird. How did I miss? I guess I must have deleted it by accident. Okay. Sine, twist, half, min, angle. So I'm looking for the sine of half, the min angle, which should be in bone joint, get param x, angular lower limit. Sine half max. Upper limit. Is that right? So it says sine twist half min. Angle's 100, whatever. Okay. So let's just say it's twist x, twist s, x and y, twist min, twist max, times 0.5, create the sine. Okay. Why do I really want to write 0.5? I don't know. What? I wrote this function. Where is it? Dist to min shorter. Why is it not recommending it to me? I literally wrote in dist. Super annoying. Dist, I have the code right there. Dmin. Dmax. Cube twist. Sine of the twist half min angle. And cosine of the twist half min angle. Sine half min. I'm just gonna double check myself really quick that cosine is absolutely just 1 minus sine. Okay, it's not quite. What am I thinking of then? Is it 1 minus the absolute value? Huh? Sine and cosine are correlated. How are they correlated? Is it the square? Well, I got it. 1 minus 2 sine x over 2 squared. Alright, Wolfram Alpha, let's simplify that. Because I might not have it right. Well, it just tells me cosine is it. I mean, I guess, why did I think that sine and cosine were correlated like this? It's supposed to be cosine of half min. Okay. And otherwise it just stays as it is. Y locked, Z free. So here's the Z. Oops. Sine swing Z, sine swing Z, half max, half min. Really want to write 0.5. I'm trying to. I was gonna do it again. I was gonna do it again. Sine half min, cosine of half min. Sine half max, cosine half max. If out clamped axis. So that won't be true. This won't be true. If out clamped axis, clamp swing wide min. Where does clamp swing wide min come from? Out clamped axis. C clamp swing Wyman. Swing angle Y disabled. Okay. Swing Y min. If get Y is not 0, I combine it with that. So this is a check to see if... Okay, I'll copy this. So I'm basically just doing this check. If you swing Y is not 0, then I'm writing this. Yeah, this is just a check to see if Y exists, and then we do that if Y exists, because it's locked, right? It's locking the axis. If swing Y locked, if Z is also locked, disables both of those. There's no other else's. Okay. Alright. And then Z is locked. Y is not locked. Z is... Okay, so this is the Y section. I'm not doing any of that. Flip the signs back. Okay. Okay, so I need to actually like copy all that. And pay attention. Essentially all that. It's not going to be Y instead. Sine swing Y half. Swing Y. Sine half max. Yeah, I think I'm kind of seeing what's happening here. It's essentially taking... In my mind, what this is doing is it's taking the parent is taking the child and saying, all right, here's, and like rotating it back to the parent. So it stays as 0. However, if there's a limit, it can only rotate so far back. So if, let's say from here, we swing out 50 degrees, the limit is 45 degrees. So what we end up doing is we say, all right, swing out to 50 and then swing back 45. So that's a 5-degree error. If it was unlocked, it would allow it to rotate all the way back just the same amount. It wouldn't do any clamping. But because there's a limit, it can only rotate back that far. I think that, to me, is what this should be doing. Which is why it checks that these are positive. Which this is effectively checking to see if it's exceeding the angle. This is that check. And this part down here is like making it 0, I guess, or whatever this is doing. Or just matching it, I'm not exactly sure. And then this one is just simply checking if we did this, which means that z is not 0. I mean, I guess what this is doing is that z is technically locked, but it's also contained within swing. So we just 0 it out and normalize it, or whatever this is exactly doing to make it only the y. Okay, that should be all of it. Literally, what's the issue there? No, go on, tell me what's the problem with that. Uh-oh, I need the 0. 0y. Whoa, sorry. 0y, 0, 1 minus y. Square root of 1 minus y squared. All right. So, I don't know, I don't really get it. Do we reset it up here? It feels a bit strange, because if the... So twist is locked. Oh, this is a no matter what thing. If we're locked, make it identity. And this is an if here. Okay, good. That's what I was looking to see. If we're locked, we just totally zero it so that every component of that is going to be an error. And otherwise we open it up so that we can rotate up to these limits back. And otherwise we're within the boundaries, so we just rotate fully back. And then here, that's an else. And then here we handle both at the same time. Okay. That comment isn't really correct there. It is correct here. So now here when I run through this should be zeros pretty much all the time. All right, try it. Oh, I need to update that. 10 days. I might make it to 2 weeks. You just hit continue. Okay. So following along, I get joint Q. Just type Q. Sweet. So my assumption is that this rotation currently encodes basically to go from joint body to joint parent, something like that. Or joint parent to joint body, one of the two. One of these is negative. Good. So this one rotates on... This is probably the tarsus, so it's probably the X, so it's probably hit it here. Cool. Though I do think I kind of missed something. Okay, so both of these would be locked, which means this would be swing identity. Alright, so I messed up. And I guess I'll probably put these inside of... Tap these in once. Okay, try it again. Get both of these, we negate that one. Swing is now nothing. I guess I'm following down here. But it's gonna scroll me up every time, so it's super duper annoying. Give a half minute, half max should be something. Alright, they look like something to me. Okay, cool. So that means we're in bounds, right? That means we're in bounds. It didn't hit, so we were in bounds. And then I dropped everything, so I can't even see. Alright, but it did take the swing off, so there's no swing allowed. And then we do have to flip, twist, although twist I think doesn't... Yeah, twist does have to be negated, right? Take both of these, I get the effective mass, run determinant checks, inverse. Okay, now constraint Q inverse should be, I think, nothing. It should be nothing. No, why is it something? Okay, well this might give me nothing. The diff might give me nothing then. It shouldn't be giving me anything. Though it is possible I still have a mistake somewhere. The thing is, these are very, very small rotations. And I think I might just have a mistake with the orientations here or something. Because I would say diff is really small, but it's actually not very small at all. I'll see what lambda comes out to be. Three zeros and a 3-7. I think it should be 0. This is 0.02 degrees, which is remarkably small, though. That is very small. So maybe it's nothing. Though that doesn't feel like nothing at all. That is quite a bit. Because this actually is in degrees now. 0, 2. That's too much. Okay. I think I figured that this doesn't do anything. Well, this does something, but this isn't relevant. It doesn't really do anything. Because here I get into, well, I call this get rotation in constraint space. I guess actually like right above it. Okay, or not. I don't know where it is. The top? Constraint to body. I think the constraint to body is probably backwards what I have. So I have these joint to body. Yeah, because I think what it's doing is I would do is I would say, let me find where this is used here. So I take the joints global transform, I transform it inversely by this, and I get a transform relative parent. So what this means is I'm getting the joints transform relative to the parent transform. That is not exactly what this is doing. Yeah, it's actually not right at all. This is supposed to be taking a transform, and when you apply it, you end up with the parent body space. Okay, I'll see how they calculate that. Constraint to body. So constraint to body is... Oh my gosh. What? Is there a different place this is calculated? No, this is it. So I take constraint to body times body transform inverse. And I guess I can assume that constraint to body is just the transform. It's just the joint transform. Constraint to body, I think, is very clear. It means, like, if I'm at 0, 0, I have the normal default orientation. I say this constraint body times nothing will get me this result, I think, is what that means. It gets me this result. So this might actually be correct. I might just be doing it kind of in the wrong order. The way it's written though is like inversing it though. Because assuming I copied this part right. You know, since I would continue down here, I feel like I should probably bring this up. Probably makes sense to put this as far up as I can get it. Yeah. Wait, I do have to still rotate it first. Okay, so it's actually more like right here, and then I would run this. Because I need that, I need the updated inverse inertia tensor. And then I get that. Alright, cool. Let me think about this. Constraint to body. So essentially saying, like, literally I take a vector, I would say 0, 0, apply it, and then I would get, I get this transform out of it, is what I get. So then that's correct. Okay. So is it correct? Oh. I think it's not exactly right. No, constraint space to constraint space to body space. It might be the inverse of this. I take a transform. And I get it relative to the body. It might actually just be the inverse of these. I don't want to just like try it. It seems really bad. But I'll just try it. Yeah, this seems wrong now. In my mind, joint Q should be almost nothing, right? Well, it should contain whatever angle is rotating by, but this seems like way too much of a rotation. Just sort of step through it. I don't get it. I don't know, maybe this is right. Yeah, it's not right. Because that's just a huge limit that technically just applied. Yeah. It's like 180. Right. Yeah, that's insane. Okay. I just think that somehow... Alright, let me start from the top. I think I see it. This is the first operation that I do. But then I technically do it by this. And this is Q. So this is actually wrong. Body 1, flip these two around, so joint to parent times parent. inverse. And then this is multiplied by this, body 2. So I need to have joint body like so. And then that's all multiplied by joint to body 1. Okay, so I did have that wrong immediately. I did immediately have that wrong. It's so annoying that Godot flips everything around. It's fucking crazy. It's bonkers. I feel like they did that because there was like one situation where they had a typo and they're like, oh no, this totally makes more sense. So they just flipped everything. And now in like all of your code, any legitimate code, I have to write everything backwards. So annoying. Transforms the right by this. What are you talking about? Transform this one by the right. Order of operations. Okay. Let's see what this one does. Okay. So it contains a pretty small rotation. I say pretty, I mean that is pretty small, I think, for a quaternion. Swing is small, twist is also small. Twist is really, really small. That's the one that's technically allowed to rotate. So swing will be fully limited, and then this one shouldn't do anything. I guess I should check before I... Both negative, good. So in theory, whatever that encodes, and then this should encode nothing. I don't want to see X at all. I'm back to the same value. That's actually weird. I'm back to the same value. That's the same value. And this is going to do something ridiculous. Yeah, O2. How does that work? How did I change the order of these two and it did that? It would be so nice to be able to step through this and like have this just run. So I can see exactly when I have a problem. Okay, constraint to body times body 1. Inverse. Body 2 times that. And then constraint to body. Joint to body times that. I mean, I don't even know if this part is right so far, but this part, maybe it seemed right. Okay. Let's get down here. So I do that. I do, that's Q. I'll solve with Q, constraint body 1, constraint body 2. I get swing twist of Q. That's Q. I clamp. Swing twist. And I have the order wrong again. So then what I say is joint parent, or joint to parent. Swing times joint to parent. Twist times that. Inverse. That. And then I do all of that times joint to body. Okay. Then I get here, and it will be that times body, and then that, and then body 1 parent inverse times that. Okay, I flipped another one. So yeah, so far this one seemed good. Because it looks like the twist, I guess you can probably hit that and see. .7 degrees, right? Those are some large angles, but I'll ignore those, I guess. Because those technically get fully limited, but I know that they do. This is the one that's more concerning, if that comes out to be wrong. So I end up with these both being very negative, because they're well within the range. And that seems correct to me. Still don't exactly know what that is, but I'll see the angles, and then maybe I can get a better understanding of what this means. So I do happen to know that due to the shape of this is the front leg, this is this joint right here. This is very nearly 90 degrees, right? So to me this says if I take body 1 and body 2, I rotate it almost 90 degrees to get it to its position here. So somehow then this math determines that change. And that still just seems wrong. It still seems dramatic and excessive. Three zeros and a 3-7 is still what I see. And this wants to rotate over a half a degree. So in constraint to body, M constraint to body 1, M constraint to body 2. Can't be correct. The error is too large. If constraint to body 1 takes an orientation and rotates it into body space, what does that mean when I pass in the body itself? Well, I guess what that means is I'm actually just taking if it's constraint to body, if I'm taking joint parent, so just its orientation and rotating it by the rotation that turns it into, that turns a constraint into because I think joint Q comes out correct. It looks to me like joint Q is correct. Because it's almost nothing. Maybe it's not almost nothing, because these are not insignificant rotations. Because this is frame 1. This should have almost nothing happening to it. And okay, this might already be wrong then. 10 degrees seems excessive. To be off by 10 degrees after 100th of a second seems really excessive. Okay, so I think it might already be wrong then. What I think it's probably meant to be is it probably is meant to be the relative offset is probably what it's meant to be. It's probably just meant to be the offset. So I know what that calculation should be. Should just have it in part, I think. This, right? So maybe I just take offset. But it could also be in the wrong direction still. Okay, so let me consider this then. Let me read this one because this one actually makes some fucking sense. So I take body 1, I translate it from constraint to body, which I don't know, it's kind of a weird thing. And I take the inverse of that. So this means I'm getting this transform like this. Oh, it's so fucking weird. I broke my brain getting into Godot's backwards mindset. And this is difficult for me to understand now. And it's even funnier because they actually write this out here with parentheses, even though transformations, even though there's no parenthesis here, because it's reading from left to right. In Godot, you have to read right to the left. In Godot, actually, sorry, it's extra fucked up. It's every transform is right to left. So if I have this times that, I apply it that way, and then I apply this back into the whole thing, and then this back into the whole thing. It's just fucking extra backwards. It's so terrible. Let B1 and B2 be the center of mass transform. I don't think that exactly matters. That it needs to be a center of mass transform. Also, it says Q. Okay, well, it says B1 and then it doesn't. Whatever. They just changed B1 to Q. M constraint the body. Q be the rotation of constraint in constraint space. I don't understand any of that. Whatever. Get rotation in constraint space. Does sound like exactly what it means. It just means that it is the offset relative to parent 1. Relative to parent 1's constraint. So I'll try this. Body times constraint. Body times constraint. Yeah, essentially, definitely the idea here is that I get almost a non-rotation. I should get nearly a non-rotation. Think of this as the position of body 1 relative to the position of the transform of body 2. Relative to Am I writing that wrong? I take this and transform it by the left. This transform by the left. Yeah. I think it is meant to be like this. Because it should really be like almost nothing at the start. It really should be almost nothing. And then this is creating the swing and twist of this constraint. And this part seems definitely correct. And this now is something interesting. So if I read here, it looks like I take body, it looks like I take parent, and I rotate it by these two. And then I take body one and I inversely rotate it by this. So in my mind, this is like taking this one, rotate here, and then I take body two and I rotate back. So this is getting body two relative to this. That does seem a little bit wrong somehow. Because then it's like I take joint body, I rotate it backwards, and I get that relative to the parent. So this bit just seems a bit odd. I feel like I would just say the swing twist. Yeah, I mean, I feel like it might be a little bit extra. Because if these other ones are doing what I think they're doing, this is basically creating a twist and swing that technically encodes that offset, but then limited in some way. And the idea is I would essentially just take the body, inversely transform it, and then check that against, or sorry, this one's actually going backwards. So I'm taking joint body, I transform it, yeah, I mean, it says inverse. I transform it backwards by this. So that means I think joint to parent must be wrong. Because this part just doesn't seem right at all right now. Constraint rotation inverse. Yeah, that doesn't seem right to me. So why does it... Why? Why is it like that? I don't know why I'm writing it like this again, but I guess I am. Because in theory, yeah, I think it is just like taking the parent. But in such a way that I think I can just write it all out in one go. Because I know what this is really doing. This seems like it's overcomplication, where it's essentially just doing some math just to effectively get this. Really. So I take parent, I rotate it by this swing and twist, and then I get that, and then I get the body relative to this. So I'll just write what I am pretty sure it should be. Joint parent times joint to parent. And then there's an alternate way to think about what this means. This is like saying joint parent relative to joint to parent. This would be the same as taking this inverse times this. So it would be joint parent relative to its constraint. So this should get me... That's an alternate way to think about it, but it's not really helpful. This is more like taking the joint parent, or taking this transform, and I get the... I would be getting the world space transform of the constraint on the parent. I translate it by this. So now I have a constraint that should in theory match the joint body position. So then I need to get this like so. I think it's probably right. Is this right? It should be, okay. This is taking a constraint in world space. That's what this is. And getting and rotating it by these values. And yeah, and that's correct. So this should now be some clamped orientation relative to the body. So then I do inverse. And I get this relative to the joint body global space. So then I get that. Now, I guess the issue to me is that I don't exactly know which direction this is traveling from. This says the body relative to that. So it should be the case that I have an error. I should be doing the opposite of this. And then parent is then doing the opposite again. So I'm not exactly sure. There's a few too many negative signs, I think. Subtract body 1, add body 2. So this could be backwards. This part is just kind of difficult to follow. I don't quite get this part. I take body 2 and I rotate it backwards by this. Not body 2. I think these ones are probably just incorrect. I have the wrong thing here. So because that is wrong for me, or that's a different thing, I need to write it in this way. So I take that constraint, I rotate it back. Inverse initial orientation. And I take body 2. I rotate it that way, and then I rotate it back by parent. So what does that mean? I don't exactly know. I just know that it should be 0 for the most part. And this way kind of makes sense to me. It's more, the part that I can't follow through is the fact that it's the constraint stuff. Constraint to body 1. Body 2, I rotate it backwards. I take parent, I rotate it by the clamp thing. And then I take body 2 and I rotate it backwards like that. So now I have body 2. But then I get here, or this is the orientation that I have. And I take body 2 and I rotate it like this, and then I rotate back by the I don't understand exactly. It's like a double up here. And it's odd. But this is okay, you know what? Actually, this might be right then. Looking at what this does, because this is essentially the same thing, it's taking this inverse times this inverse times this. That's the same thing. Except in this case, I'm technically rotating this one by these values. So this should line up with body with joint body. On the constrained parts. I guess, yeah, like I said, I don't know if the difference is the correct value. The difference might be the wrong value. It might be opposite. Which if it's opposite, then I don't exactly know how I'm going to manage that. Joint Q should be basically 0. Yeah, that's an incredibly small value. And these should now be basically 0. Effectively 0. Yeah, Pretty much nothing. Loss of nines. Those look fun. Now the difference here, I expect to see just a 0 on the X and maybe something on the Y and Z. Okay, that's kind of hard to spot. There's a big Z orientation there, I think. 5 zeros, 1 7. The X is 7 zeros. The Y is 6 zeros. So that's good so far. Error comes out to tiny, tiny values. Lambda comes out to tiny values. Delta, remarkably small. Should it be 0? I feel like, okay. It seems like the difference still didn't come out to be 0. But I'm sort of okay with this. This is better. Five zeros and a 3 7. It's like literally doing nothing. That's beyond imperceptible. Now the issue is it could be going the wrong way. So I don't know how to figure that out. This could be going the wrong way, and if it is, then it's like... I mean, I can look at joint Q, see what joint Q is. Okay, well, I just know that because that's a negative there, I know that it's, in theory, on the positive x-axis, looking down the axis, it would be clockwise. I don't fucking know. I hate those rotations. Transforms and axis stuff. It's not intuitive ever. I don't know. It's a small value, which is what I wanted. It pretty much did nothing. This is 10, 100,000, 10, 100,000, 2 10,000ths of a degree. Pretty much nothing. What about this one? This one should be smaller. This one might even not even run. Yeah, that one didn't even run. Now I do want to see the femur. The femur should have something dramatic happen to it, because it technically is going to rotate. Oh, well, actually, I mean, it's only rotating on the axis, actually. So never mind. I only permit it to rotate on that axis. Let's hit continue, go up here and check this. Check body state. Because this one takes in a lot of... Yeah, that's a lot of angular velocity on the X. This one does have a pretty large X rotation. The Y and the Z seem pretty... Well, I mean, they should come in here and say twist is 0 and the swing is like the maximum. Should both be negative. Good. Yeah, right. Because in bone space the Y is the roll, basically. Yeah. It says only encodes a Z, which is just whatever the Z was. So diff, there is on the Z 4 zeros and a 2. Okay, I don't really like that. Seems like a lot. 4 zeros and a 5. That number is crazy small, actually. So that's good. Nothing. Well, okay, so the parent of the femur is the main body, so of course that would be true. This one, 4 zeros and an 8, 5. Four thousandths of a degree. I mean, that's still really, really small. So, yeah, okay, sure. All right. This off. Now what I want to see is when we come back. So I'll just hit continue. Okay. So I'm going to look at the part list. Each of these parts, I want to see what the desired velocities are. Desired velocity, actual velocity. Desired actual. Desired actual, okay. So we just reloaded our main body cache. We're going to go forwards. Yeah, so I want to see what this one thinks it's going to do. So this is the femur. There's the large X rotation. Which it's correct. Though that might be like a mistake, right? What does that mean? Because I know that this... So this part, though it is technically gaining this X rotation, it's technically not getting any because it's going to constrain, and even though it's going to have this large velocity, it's going to snap back. I mean, it should. In this case, technically it doesn't matter because that it kind of means nothing, I think. Because we'll cut that velocity out with the axis comparison. But this does mean that the tibia part believes that joint is going to be... Or does it? No, because when the tibia measures, it measures and says, here's my velocity. My velocity is affected by a child joint, and I'm relative to the parent and what its thing is doing, actually. So it actually thinks that its just velocity is only affected by the motor in that case. So it actually doesn't even look at that, I think. I'll check. So I measure that value. Its current value is 0046. I'm about to set it to 0017. Okay. I'm sure its target is like really near 0 or something. Or it's actually in the positive. Yeah, I mean, I don't know. It's just like suspicious that it's halfway there to me. But I guess I probably shouldn't worry about it. So rotation, I'm calculating an error that happens. That is just a remarkably small error. What is that? That is its rotation relative to its initial rotation. So I guess it's kind of read that it hasn't really turned at all, is what it's reading. It's reading no change. But there is something. Oh, IK angle is 5 zeros and a 4. Rotation error is 6 zeros and a 1. Alright, so it's kind of nothing. I'll step in. Angle, target angle. So it actually looks like it got worse. Or did it? Is IK angle negative? It's positive. Okay, so it's read that... which part is this? The femur. It's read that its rotation has gotten worse. Its target angle has strayed further. Its angle has strayed further from its target. All right, I want to see what it... Before 0017. But yeah, it wants to stop, right? I mean, it should generally be wanting to stop. 002, 001. Okay, so weirdly it like wants to overcorrect. I guess I have set up to overcorrect. It's like 5 times or something. It's currently 0017, and then I just read in that I want to go 0023. Still well within that boundary. Okay, so the delta increased. The delta increased. How did it increase? I guess it increased because joint velocity changed. But I don't, wasn't this smaller before? Or larger? A larger value? Oh, no. Okay, never mind. I am actually right. I thought these were adding together. They're not adding together. This is a new delta. And I'm merging it with the other one. Okay. So the old delta was 017, and I increased it, but I didn't double it. It increased, but it didn't double. Oh wait, no, it did double. Huh? Right, yeah, because I do have to add it, right? I have to add it. The rotation error says that I got further away. Which, if I run through this again and rotation error is still a positive value, because this should be a negative value, this should ultimately rotation error should approach IK angle so that it says 0. Okay. So I did more than double it. Because the velocity got worse and the angle also got worse. Okay. Alright, I think what I might want to do is skip ahead again until I get back. And then skip to back to the femur. So I'm back on the femur. Okay, so I see it imparting, I see it obtaining quite a lot of this velocity. Which, I mean, well, I think it's being maxed out, right? Because I reset it and then I compute this every time. So the other joints are increasing in velocity. But this one I hope to see that this one hopefully changes. So I've calculated that now it has a negative 0.004. Previously it had. Very cool. I love that bug. Previously it had a 001, and now I'm saying it as a negative 004. Okay, so it kind of bounced back. It may be that I just have too much of a correction for it, because I think it is the case that this one's set to 5, which is probably too high, possibly. And then it might be the case that's a little bit too high, but I don't know. So it looks like for now there's bad instability. Well, okay. It is stable in the sense that it is converging. I think it was like 4.3 to 1.7. So it's done this thing. It's done this jump back and forth. And then I can't see it because it doesn't. This freaking inspector doesn't show things precise enough to see those values. Because it just says 0, so I don't know what it was before. Though it is still getting worse. Which maybe makes me think that this could be wrong. When I say get angle, what exactly does that do? A cosine of W. Okay. I think my mistakes might be that A cosine W actually is giving me the correct value, and I shouldn't be inverting it. It may be the case that I shouldn't be doing that. Wait, no. I'm actually right, because A cosine is always a positive value. Never mind, that's actually right. Five zeros and a 4. 6 zeros and a 2. Target velocity is still roughly the same. So it should give me a positive value. It doesn't seem right. It's like doubling every time. That's a more than double. Okay, I want to see if this is applying correctly. So clean part state will load in everything, right? It sets it back to main body, back to the initial input. And then I want to go to the femur part and check this rotation is applying correctly. Because I have a feeling it's probably not applying correctly. Calculate part velocity. Okay. Zeros. Okay, so since angular velocity is 0.0046, desired motor velocity is 0098. Why does it say joint velocity is negative? I think something in here. I think something might be backwards. Joint velocity reads negative. This reads as some negative value. So yeah, this should have read negative. And then add that desired velocity. Is this the mistake then? I think it might be. I think I'm computing the joint velocity wrong. Okay, yeah. Because it's doubled every time, something is definitely wrong somewhere. Is it that because I see joint velocity and desired motor velocity, and what I'm expecting to see is that these two are going to change. So yeah. Yep. So desired motor velocity is happening. I'm ending up with that, nearly that velocity on the joint. But then I'm somehow measuring joint velocity incorrectly. So is it instead that I actually do need to subtract this value? Maybe that's the case. Maybe I do actually have to subtract this value. It's in a weird way because what it does is it passes that okay, it's in the setup. In velocity mode, it passes in the negative angular velocity. Negative target angular. That is the mode rotation constraint part, which is an angle constraint. Which the angle constraint jeez, when running that way is to calculate constraint properties. Two bodies, an axis, and then a bias. So let me say calculate spring properties with bias. Which just sets it to that. So this would be returning. This just comes out to be 0 because softness sets to 0 when you do this. Softness 0. So this just returns the bias. So this is to subtract a negative, which is the same as adding the value, which is what I do there. Then it seems like it's clearly incorrect because either the axis would technically have to be negative just because of how things are working out. So I think here maybe I do need to subtract it. because I'm actually getting the result that I want, but I'm interpreting it incorrectly. Okay. What do I miss? What misses here? Applied step. Mass times axis dot parent minus body minus bias, which technically the bias is negative. So we minus the negative desired velocity. What axis? Parent minus body. And then apply step, body 1, body 2, lambda. Minus body 1, add body 2. I mean, okay. I can definitely say that whatever I set desired motor velocity to, I end up applying the opposite. So honestly, this could be like an additional negative is happening, where I mean, I guess I'll see what I do, what this does then. I'll look for what happens when I set the target velocity on a generic 60-degree freedom joint and see what that does. Angular motor target velocity. What's the method? Oh, set param. Can we not have these crazy things? Set x value. I set the value. Is it just like the axis is actually inverted? Is that actually it? I have to invert the axis. Is it my... Maybe it is my measure. My measure of the velocity might be wrong. I don't think it could be wrong because I am just reading it is parent. It is parent minus. It's the same value, right? Okay. This has to be a negative. This has to be a negative. I've figured it out. Or I've determined that this is what's wrong. But I don't know why that's wrong. I really don't know why that's wrong. This has to be negative. Because I think I'm simulating them applying the wrong things. If I measure it this way, here, I measure the velocity like this, which is correct. And then I measure it the exact same way up here. It is parent minus part. Exactly the same way. This has to be a subtraction. I don't understand why. It's likely the axis. A difference in how axes on that works. Which basically means that when this constructs, this has to do the opposite, right? This has to construct in reverse. But that doesn't make sense either. That really doesn't make sense to me. I don't get it. Okay. No, because I see that it's negative and I pass positive and it becomes it's the part relative, it's body 2 relative to body 1, right? Always body relative to parent. Always body relative to parent. Input, my target. So this gives me Target minus input. Target minus input. Who's wrong? Because there's someone's incorrect. I read in a negative. I say I want to I say that I want to increase my velocity. And then this value becomes what? This would be a negative 0.4. I say, all right, add 9.8. This comes in and says, okay. Add 9.8. So is it actually correct? And it is just like, what? Femur. All right. So part currently has part state angular velocity of 0046. Okay. Which is quite a lot, actually. That is quite a lot. So I compute joint by saying parent minus that. So I put the joint velocity of this. Okay. I'm just going to assume that came from the tibia adding that or something like that. So that's what I calculate velocity to be. I say it is currently negative 46. Negative 0046. Right? Okay. Angle target. That looks good. So I want it to be a slightly negative value for the velocity. So I should read out a positive acceleration. I'm going to say, all right, we need to fix that someone else is moving us, basically. Yeah. Right. So this seems fine. Okay. We want to be basically 0. Our current value is some negative value. We make our desired value some positive value. Right, so I want to see what this is doing exactly. Parent, a positive 4.6. So I calculate the parent to be pretty much unchanged, I guess. It should be relatively unchanged. But I have apparently reduced its angular velocity, I guess. And myself. Slightly increased that angular velocity and didn't really touch the other ones. Right, so this should be, yeah, the femur. This is a very large value. Okay, so I just want to see if that was being affected by that one, and it's not. Okay. So again, in here, that's the velocity. This one should basically be zeros. Yep, pretty much zeros. We have a torque. There's the axis. Here's the part. Desired velocity is 017. Present velocity is, or 0017. Present velocity is negative 0046. So essentially it's saying whatever it takes to zero this out, plus whatever this is. So I should see negative 0046 plus 0017. Does that make sense? Maybe that doesn't make sense. It doesn't seem right, does it? It really doesn't seem right. Should I actually be subtracting it? I don't know, I'm so confused now. Because parent won't move. This one says negative art state. Let me check. Okay, this one's positive, right? So this has a positive 4.6 angular velocity. So I say, all right, let's zero that out. So I actually end up with the negative of that. Okay, so this is actually correct. And then I add a little bit because I want to take off less than that. So essentially I'll be taking off 4.6 plus, but a little bit less than that because I've added this. Okay. So I'm sure this is actually right then. Yeah, okay, I'm sure this is right then. But it does seem like it reads it wrong, actually. It still somehow reads it wrong. Because this is definitely the case that I said, make my angular velocity. I mean, yeah, I technically got what I asked for, isn't it? But I did intend the negative of this. Well, actually, no, how is it, no, because then this value would decrease. Yeah, the angular velocity has gone from 0046 to 0017. So now I come in and it says, all right, our velocity, the joint velocity should now be smaller. Is it not really applying them? Like when it comes back around, is it not the same? Is that what's going on? Yeah, it achieved the velocity that it wanted. It achieved the velocity it wanted in a single step. It was able to get there. So it should go in the next time and say, our velocity is 1.7, our target is 1.7. Or no, our velocity is negative. No, that's actually right. It'll say our velocity is negative 1.7. Our target is negative slightly 0. So it should just say to change it a little bit. So maybe it's the case here that I update the velocities. No, this is the velocity update. This is the rotation update. So velocity update's good. Do I accidentally apply? No, it's good. Does the state not update? Is that it? I end up dropping out of it and the state doesn't update. No, that's right. That's what it was. Yeah, it's this. So I rotate it with that velocity. I say, all right, so we're going to pretend that we rotated it with this velocity. I think I understand. Because when it comes back, it's cleaned the part. So it thinks again, it's reading the wrong thing, isn't it? It thinks that once again, it didn't change, essentially. So it adds the same value. I save this and I remember this. This doesn't. Is that the mistake? I'm doing this, I'm not supposed to do that. Wait, no. It's still correct because I just reset it and then apply what I calculated. Where does it go wrong? Yeah, this is correct. I rotate by that. So that's the value that I wanted to have. So these changes will stay here when I loop back. Okay, so I want to see that loop back. And then we go forward this time. So I should see the same values that I had set. Yeah, that's what I had set last time. Good. So joint velocity is basically nothing there. And then I'm going to step in here and check this. So parent should be mine. That's correct. And then it shouldn't really mess with this, I think, because it's only going to rotate on the axis that this one can't rotate on. Yeah. It's such a small value. So it looks like this case, the difference between these two is about 0.1 or a little bit more than 0.1. And this one's desired motor velocity is 0.03. So its desired is 0.03 and it looks like the actual is 0.1. Yeah, I mean that's roughly what I said, right? It looks like nothing really changed either. So last time the joint velocity was 0046. It's about to be set to what should be negative 0017. Good. So this value got closer to 0. And technically matches what it wanted it to be. I think it does technically match what it wanted it to be. So I guess we'll find out what... So joint velocity here is negative 017. I step in. So target velocity is also the same sign as it was before, just negative. So now I should read definitely a smaller acceleration, right? Something seems wrong now. Something must have gone wrong just now. That doesn't make any sense. Yeah, what? That doesn't make sense. This value definitely should have been smaller. It's larger than it was last time, which does not make sense. Where's the mistake? This bothers me. This isn't right. The error in this case is smaller, and yet the result is larger. Why is that? Memory 0 is memory 0, which would be 0 plus a0. That's a constant times 0 plus, I don't know, times target minus input, which is a small value. Plus a1 times 0. So did the cache load not work? Jeez. So, what just happened there? So I'm going to continue. And get on here to the first part. Continue. Okay. Check part. Motor controller. So let's see how this is possible. Mem0 is not modified here, right? Yeah, Mem0 is not modified. So Mem0 is set to Mem1, which is currently target minus input, times a small value. KP and K are both 1, so this is just delta is 100th, so it'd be 1.001, right? So I add the full error. So Mem0 is 0 plus the full error, and then add this one, which would also just be 0. Yep, Mem2 was 0. And it would be the opposite of that, so it would actually just do nothing. So in that case, then it should be 4.6. 0 should be 4.6 at this stage. And then I get to add this, which means it looks like somehow it overrode it. Which I don't understand how that happens. How does that work? How does it override it? Okay. Let me run this again and try to comprehend what is going on with that, because that is kind of nuts. So first chain. I should just be able to jump into the first one. I'll skip over that for now. I'll skip over that for now. All right. So this should be okay, it's the wrong part. Continue. Continue. Okay, here's the femur part. Mem reset. Mem reset is what I'm missing, isn't it? Yeah. Okay. Do I call store cache? I think when I call store cache, I have to remember if I'm waiting for that to happen. If mem reset was true, then So I was missing that. Okay. Well, there it is. There was the instability. Okay. So we're gonna continue, and then I get to see all the femur stuff, because I determined all of that was pretty much good. Right, angular velocity is what I want it to be, what it was should have been calculated to. No motors yet, so this is all just normal stuff. I calculated it to be, yeah, roughly what I want it to be. Set that. The smallest ever rotation error. Okay. Step in here. Memcache reset was on, because this always happens. Well, in this case it actually doesn't care, but this one in this case do care. Apparently mem reset is already on, which I guess it would never have been set to false for this one because this one doesn't run that mode. Target velocity just calculates the same way. Now this one, I really care about it. So mem reset is off, memcache reset was on. So I'll set to 0, and then I will turn this on. Very important. Jump in here. And then we're going to run this again. So we load in that input. Calculate my values. And the only thing that should happen is just nothing. It should say 0. Yep, so it's become 0. And then all this math goes through and computes this small value, and that becomes the result. Good. So last output was 1.7, current output is 3 zeros and a 6. Good, good, good. Ouch. And would you look at that? That happens to look very similar to what the output used to be, actually. Because I think it used to be 0017, and then it would output. This delta would actually come out to be 0023, and that would add and begin to snowball. So now that's correct. Cool. I'll step out. And then I guess I will probably just hit continue again. The next one. and then it's going to run backwards. So skip to femur. So I measure this one's velocity to be about what I set it to. Recalculate joint velocity. Though it does seem like it hasn't approached what I wanted it to be. Yeah, okay, I was thinking this is still probably a problem. Because it's not setting. Who's wrong then? Who's wrong? Who is wrong? I'm following the math of the physics server. The one thing that does not follow is what I say the velocity should be. Well, it's weird because I said I want the velocity to be 0.0017. And then, all right, you know what I think it is? I think it is that when I read in the velocity, I need to negate it and say, if my desired is negative, then I want to output a positive. Because it seems like it's matching exactly what I want it, what I'm trying to set it to be. But maybe it's more like I should be I could just subtract it, I guess. I could just subtract it. I hate it, but I think that might be what it's supposed to be. Because it really is like I'm interpreting it wrong, right? Because it's like I read in that my desired velocity is no. Who's wrong? Who's wrong about it? Someone's wrong about it. I mean, obviously someone's wrong about it, but like, I'm not sure entirely. There's a fly. Really bugging me in here. Okay. I need to go get something to eat. Maybe just take a short break. So I'll be back. I'm back. I've got food. I'm trying to think about this. I read in that I want to have a 0 velocity. I say, okay, our velocity is negative 004. I want to be 0. So I set my velocity to positive 0017. The torque is enough that it goes through there and it will set it to 0017. That's what I should do. What has actually been happening is I say positive 0017, it sets it to negative 0017. Right. So then the next round it comes around and says, okay, our velocity, we want to be 0. Our velocity is now it seems wrong because in the next run around it says, okay, we're at negative 0017. Let's fix that and say to add some small value. So then I say, all right, now my velocity is 0.0023, and it runs through and says, okay, our velocity is now negative 0023. Right? That's incorrect. So I think it's more that this plus is correct. That plus must be correct. My output, when I say my desired velocity is positive something, I think I should be providing the negative velocity. No, I think it's that I get down here and I set this as the negative of this value. Where's the mistake? Because I say velocity should be positive 0017 and it comes out to being negative 0017. We reach for the negative. But I mean, that's also just technically correct. It was that second run that showed me that was wrong. Because then the velocity will come in as negative 2.3. And it still wants to be 0. So when I say positive 17, the expectation is that it runs back around and comes in as negative 17. It's here. It's wrong here then. It's wrong here. Joint velocity comes in correctly. But it's my output is wrong. What would it normally be? It would normally come in here and say our velocity is negative 046 or negative 46. Our target is negative 17. Or sorry, our target is negative 0. Negative 0. It's 0, right? So I get a positive output that says, okay, so 0 minus this negative, we want to accelerate. In a positive direction. I want a positive acceleration. A little too loud. So I say, all right, let's go to a velocity of right, I say should it then be the negative then? Is it just that? Because I end up applying that, and I actually apply it backwards. If I say positive 17, then the angular velocity is yeah, it should be flipping. Okay. I guess it was. This I'm not convinced because I'm sure that I've copied this correctly, but it just seems like when I say positive 17, I expect the result to be positive 17, not the result to be negative 17, because that's what this was doing otherwise. This would say, all right, let's correct for this negative 46 difference, and then let's add on. Let's correct for this as well. Because then the next run around should say, all right, Our desired velocity is pretty much 0. And we're now at positive 1.7, so what should we do instead? Well, we should have a deceleration then. Should be negative on that. Right? Though I don't really like it. This is not... I don't know who's wrong. I see a T, so that's Tarsus. That's target velocity. 2328. Let me try to remember that. 2328. That tastes like it's already bad. Got that yesterday. That's no good. Or 2 days ago. Yeah, that's pretty bad. Dang. So would the error in this case be, we target minus this, so the error would be positive 0045 or 0046. I mean, okay, the thing is, I think this is sort of correct, right? But it might just be that the acceleration needs to be applied in the negative somehow. Maybe that's it. I should just be applying the negative acceleration. Because in this case, I know that's a positive angle. I would like a negative velocity. Ultimately, I definitely do want this to be the velocity. Whoa. Yeah. What the fuck? That's already bad. Dude. They give us fucking rotten cantaloupe. That's so sad. This is literally the second time I've had fruit, because this is This was just like, we got this late in the day, 2 days ago. Cantaloupe has such a bad taste so fast. Out of everything, it's always in that. We get this like bundle of watermelon, cantaloupe, an apple, and strawberries and grapes. Cantaloupe is always the first one to go, and it's so bad. It tastes so bad when it's bad. English. It's like gross and bitter. But that's the fastest that's ever been. That literally didn't last 24 hours, basically. Okay. I think maybe it is supposed to be the negative acceleration. Well, shoot, I don't know. It's there's just an overshoot here that I don't want to have. Because in my mind, 1.7 makes sense. And then I say, okay, let's continue with the positive acceleration, and it's applying the negative of that. Because otherwise, this is a substantial overshoot. Because the third time this comes in here, it's going to see origin velocity is negative 2.3. All right, let's add more still. Until it's eventually built up to just say yeah, because then I think it's going to explode at that point. Because it'll be negative 4.6 plus 2.3, which would just be like negative 2.3 again. And it's going to say, all right, let's add to that. So then it becomes, instead of, it's still the case that I have a positive 2.3, and then I say, all right, let's make it positive 3. So it's going to go, all right, negative 4.6 plus 3. Plus 3.0. And then it's going to be at negative 4.6 plus 1.7 results in negative 1.7. Negative. Maybe this is correct. Hang on. Maybe I'm just like, maybe I was losing my mind and I stopped it too soon. Negative 4.6 is the joint velocity plus 1.7. That results in because the thing about this is negate the whole thing, right? It's a big negative value. So we're going to add that negative value to essentially stop it. And we have this negative value plus 0.17. So I say, all right, don't negate all of it. When this runs off of this runs here off of these results from last iteration. So it says, okay, now our velocity is negative 1.7. We want to be plus 2.3. So I guess 1.7 plus 2.3 is a positive value now. So then I end up with a positive there instead of a negative. Wait, no, that doesn't make sense. This should be starting from the fresh state. What? What? Negative 4.6, infinite effective mass, or infinite torque, right? Lambda is to fully account for all of it. So the default is to cancel this out. So that'd be negative 4.6, and then to go to whatever this value is. So let's say this was a negative desired velocity. Let's say we're at negative 0.4 and we want to be at negative 0.5. So this is a negative 0.4 minus 0.5, which would be 0.9. Which seems wrong. What the hell is going on? It's such a weird thing. Wow. We got fucked. Actually, that whole thing is bad. That strawberry is bad. The grapes, I'm sure, are probably still gonna be good. I can see it's already soft. It tastes weird. That's upsetting. There's no way they looked, because they know how long this stuff lasts. They gave this to us probably when it was already marked expired. They must have. Like when it comes to fruit and there's the Best Buy, that Best Buy is really hard. It's a hard line. Like you can be sure it's gonna last about that long and then you shouldn't touch it anymore. Because it's gonna start rotting. He definitely saw that on the can. We're like, yeah. And the strawberries. We're like, yeah, okay, put them in there. Serve it up. Expired yesterday? Okay. Or at the very least, it's on the shelf somewhere and they're not taking it off. It's like one day out and they're not taking it off the shelf. It's one thing if you're like serving the fruit the day before. But if you're selling it in a package, I think at least a week. Once it's within that week, you should probably stop selling the package. I mean, if it was all going to be eaten that day, it's probably fine, but, like... I don't know, maybe they should be labeled. I don't think there's labels on the packaging. I mean, typically you don't need to label fruit because you can just tell by looking at it and tasting it that it's bad. Do I have the lambda and the torque wrong? Because I may have it wrong. I wonder about that. Smart translation. Min torque limit, max torque limit. Delta time. There. So I get the torques. This is the angle constraint. Body minus the bias, which is actually just going to be plus minus the negative desired velocity. So add the desired velocity. Clamp that. So I'm not running a tally of it. This just is the total every time. Which means when I do this, these values have to be the reset values. But they also can't. What is this? What is this? What is this? Am I doing the wrong order? Body 1, body 2? Still so confused by this. I can take this off now. Okay. I just need to run this and see it one time. Four zeros and a 9. Like this is a pretty large value, right? Uh, desired motor velocity is 0. That's not right. Why is desired motor velocity 0? Oh no, I guess that's right. Yeah, no, that's right. Heart state, parent state. I actually don't know which one I'm looking at right now. Tibia. I think this is the tarsus running the tibia, is what this should be. Yeah. So the parent in this case is yeah, this is the joint between the tibia and the femur. And this would be applying a torque on the targeting 0 on this axis, so mostly the x-axis, targeting 0, which means the x-axis 1248 negative 1248 negative 0438. So with the desired velocity of 0, it should just be applying the negative to everything. So the lambda here is negative. So that means it's also mostly on that x-axis. Wait, what is this? This just seems incorrect. Well, I guess that's just the inverse mass, isn't it? Yeah. Jeez. So we'll be taking this one and subtracting the negative. So this should bring it closer to 0. And the other one will be adding a negative. That's just weird. How does that work? 05. Negative 0438. Lambda was negative. No, I'm confused. Because this brought the velocity of the other one further from 0. Inverse I2 axis. That I don't understand. Why did that happen? This was allowed to have the maximum torque. Sub-angular velocity step, add angular velocity step. Not this one. Body. Is it lying to me? Okay, we have the inline file, but we've defined the inline functions not in the inline file. Right. Angular velocity minus equals velocity change. I kind of don't get it. Okay, no. Yeah, I just got it. I understood it now. Okay. That's right. These should be approaching the same angular velocity, right? So this one has gone down and this one has gone up. So they're approaching the same angular velocity, so the total between them has definitely decreased. Though most of it was focused on the femur and slightly on this one. You know, might change that. I think the grapes are bad too. Dude. Okay, this is great. This is great. I think I'm still looking at the wrong spot. No, that's the wrong spot. Jeez. Okay, so 0046. Torque is 09. Okay. This says desired of 0017, which technically means negative 17. Because the correction is to do all of this. Right, let me just see if lambda is clipped. Lambda is not even close to being clipped. It's incredibly small. One 17619. Zero zero 1736. Okay. Okay. I think I'm convinced that I do mean the negative then. Needs to do something else too. This has to... I don't even know how, but I need to like store this lambda. Because otherwise I will be applying too much. Well, I don't know, because I reset it and that's what I leave it at, and that's what I operate on the next time. And then I come back and say, I apply it twice. So should I not be doing that at all? Maybe I'm not supposed to do this at all. Because this actually causes a problem where this is, I run through, I compute it, I clear it, I compute it, and then I come back and then I calculate it again. I calculate this again. And this is incorrect. I should not be estimating it here. Though I could estimate it here. It just means that when I run this, I have to clear it prior to checking. Which would be annoying. Because I have to clear it and then unclear it. Or maybe I do just mean to clear it at the start every time. No, because that needs to incorporate the angle errors and the velocity errors. Maybe what it's meant to be is the velocity error is meant to be that change in velocity. Which this does include the change. This is the last run's leftover amount, basically. Okay. I think doing this might just be wrong then. I shouldn't do this. I shouldn't estimate. Because this is the estimation. This contains the estimation from the iterations. Okay. But you don't want to recommend me the first one, but then you want to recommend the second one. There it is. What's your problem there? Parent state. Let me just do this. That part's good. They should only be reused one place. Yep, good. I'm sure of that. Because if I say I want a positive, then that means I expect the relative velocity to be positive. Not the same number, but as a negative value. Because then what's going to happen as I go back around and I say, okay, my velocity after that iteration was actually to be too much. So now let's decelerate, right? Our incoming is positive 0017, and our target is a slightly negative value. Basically still just 0. So then we come out and say, all right, let's subtract something. But knowing how this should be working, it should be that's like the low pass causing that whole thing to happen. But it's also odd because it is a change. But it's also the case that this comes through here and says our desired velocity is 0. So let's correct for that with this torque. And it still happens to be that it was wrong. Okay, but that's okay. That's where the estimation happens. I guess the issue is that it's starting with an overshoot, which is wrong. It has started with an overshoot, and it shouldn't do that. So why did it do that in the first place? Let me just run it. Because I don't get it. Because I think this should have ended up saying, oh yeah, we don't need to do anything. Because we've already fully canceled. Our desired velocity was 0, and we know that. So I believe here we should be matching the x velocity. Yeah. So these two numbers should just become the same value. Negative 0.4 minus 1.8 is like negative 0.2. Yeah, negative 0.2. I'm assuming the next one. I'm assuming that they should both just be the same value, right? Nearly the same value. Super, super close. Right? So... why does it say to do anything then? So I'm looking at the y. Is it the case that I wasn't actually doing this? I wasn't really doing that? Maybe that was the case. I wasn't actually measuring that. Okay. What have I thought of doing here? What was the idea of this? What was written before? It's just a fake loading bar. Okay. Like, what? Why? Why do they lie about the loading bar? What was here before? Okay. Yeah, I think what was missing here is that I didn't actually add on what it's going to already be doing, which is I think what I should do. I should estimate what it's already going to do. So I should be taking these results, right? I guess I'll do this. I guess the idea is probably just take the average between them. So what I do is I calculate the first one. I guess I can just do this. And then it seems like I probably shouldn't need this. So I estimate these two. And then I want to estimate the parent. X minus 1 is greater than or equal to 0. Estimate parent. I guess I'll probably just copy this. Estimated parent, angular velocity. Right. I mean, it's probably not a really good estimation. What it probably should be is to run up the list. Okay, let me do this. It's the velocities, right? Okay. Let me say this then. I do not run that, and I don't use those values. I give it these values. So then I'm able to pass them in, and it can modify them in place for me. And yeah, let me change this to not say results, instead be. I guess I'll just call it velocity. Can I call it velocity? What a short name, but I'll call it IO velocity. This seems okay to me. Okay. I wanna start high and draw in. So whoa. So if I'm on tibia, then I want to say, all right, let's get the tarsus, compute that joint and what it does to me, and then I say, all right, now I have mine. Now I want to compute yeah, compute what that joint does, so then I have a better result, a better starting place for where I'm at, and then I look at this joint and I say, No, then I would look at the higher joint, the lower joint, and say, all right, what is that going to do to this body? And I say, all right, now these two bodies, what's going to happen? What do I think my result is going to be there? And the whole time I'm just running through with the velocities. Okay. That should be part count. Yeah. So I get that part, and then I need to my state is that one, so I just need to get that one state. There's going to be part velocity. That one. Right, so then this one is now my new velocity. Current part. Super parent state, I guess. And then I now have the estimation. And now I'm actually making use of the fact that I have two of these. So I'm not just totally wasting the calculation. It's just one addition or subtraction that I could technically avoid sometimes. Or at least in these two cases. I could avoid one of them, but that's not. It's whatever, because I do it again here. And the only issue is that the torque is definitely wrong. It's going to be an overestimate for what's going to happen. Which is probably wrong. You don't really want to overestimate, because then you can overreact. Because I'm sure sometimes this will be hitting, and it will be meaningful. Maybe it's just this part that I shouldn't be doing here. Because I technically already estimated it, and I don't really need to know this. Because the estimation always runs with, okay, well, what are the motors going to do right now? And what's the result of that going to be? Assuming that the other two happen and then I happen, right? Making that assumption. That joint has the final say. I mean, maybe what I can do is just say, I mean, yeah, I think it probably is that I need to clean this, right? But I'm not sure. Because I think the input might be... I don't know, the estimation comes in and says, all right, doing what we're doing now, what's probably going to happen in the future compared to what we want to happen? And then it comes back around and says, all right, doing that, here's what it's going to look like. So we make a small adjustment to that. Because every time this iterates and comes through, we change that motor velocity and the torque, and that affects what the estimation is here. That affects this estimation. But then this part is to get the angle error, which I think matters. I think that one really does matter. We rotate it, then we constrain it. And I mean, maybe this part should just be first. But then I suppose part of the feedback is that it no, the feedback is that the motors have changed. That's the feedback. That's the feedback loop. So this should be first. Well, not this part. This part. Well, yeah. I estimate what's going to happen. I move them. So then I get the rotation error. And then I run with that. And then down here, yeah, okay. I think that's it. Because I... Yeah. And then... the initial... I mean, yeah, I guess I just apply that on setup, and then every time I run, I just have those saved. I don't need to clear this anymore. Though I will probably be modifying it. Yeah, I literally don't need to have that. Is greater than 0. And yeah, do state update wouldn't be a thing anymore either. So yeah, this is the first thing that I do. So I estimate everything by moving it. And then this, do I even need to account for this now? I think I don't need to then, because I'm just running. Because yeah, I think I don't need to account for that now. That's actually counted for. So I don't do this. What am I trying to estimate here? Okay, I think this is where this part is the change in how the estimation is. So I run it in whatever order I mean to run it in. And then here, I guess this one doesn't really matter because I'm just checking the exact thing every time. and then I'm not actually applying those things to it. And then all of this is going to move up here. Though I guess maybe it doesn't really matter to run it in reverse like this. Maybe we should just always run it in the same order. I'm deleting a lot of stuff now. Don't do any of that. Just doing indexes part count. So update all the velocities. And then I update all the positions. And I am not setting as impulse here. It's not relevant. Supposed to be unpowered when entering forward, so break early. Yeah, just if we're not powered or we are broken. Okay. Um, yeah, I think I don't need to do that. I think I don't need to do that. So this should only be getting delta now. Um, say that. I mean, I guess I could always run it afterwards, right? I could just always do it. Just do that. And then this would not be doing any of that because you've already estimated it. So the first thing this does is apply all the estimations for what's going to happen. And then we start working on fixing against that. Hey, Danilin, I will not believe it. What will I not believe? So these two should equalize their x angular velocity. And they essentially did. Very nearly. These two should also be doing the same thing. nearly equalizing it. And they kind of got there. Not really. But they did, sort of. And then this one should be equalizing the y. So I guess it's probably like... no, that's wrong. Hang on. Something close to 0 for the second one. It should reject any change to that middle one. Yeah. I found your cousin at the convention. You didn't. You gotta stop saying that. You just didn't, because it's just not true. All right. So then I will assume everything to move in the way that it does. So this should be applying the rotations. And then applying the limitations. We'll send a pic later. Yeah, okay. Alright, so this is between what? Well, actually, I guess I don't know, because those are kind of small. Yeah, okay. Yeah, body, yeah, so this is tarsus and tibia, of course. Where is it? What is this? Yeah, tarsus and tibia. How does this one have a much larger X value? Inverse, because it's inverse. It's larger because it's easier to move. That's how that works. Okay. Joint Q something. Essentially nothing. I might just skip through this bit of it, because this is... Yeah, okay. Step in, so now we'll see what has happened. Part velocity. These should generally be really similar, though they're not going to be entirely similar. Or at least on the X. So yeah, 0272, 020. So there's a small bit of rotation happening. And then a rotation error. 3 zeros and 2, what would that be? Not even a degree, okay. Not even a tenth. 100th. Okay. Step in here. We want it to be at 0. Seems like we're still at 0. Well, yeah, we haven't done anything yet, of course. So that's the IK angle. 5 zeros and a 3. Rotation error is larger than that. Okay, so that's good. Sort of like in the opposite direction. So what is the result of this then? And I guess now this really goes into the realm of using this for error correction. This is like, yeah, I've written like feed forward now, right? I estimate what's going to happen, and then I use this to correct for that. Velocity is 007. Negative. Target is positive 001. So it should be a little less than plus 008. Okay, plus 004. Right? So now what I think I'm going to do is I'm going to hit continue, just jump forward. And now look at the new estimation. So these are the present velocities, looking at the x. So it's 04, 02. So it's like negative 05. Well, that was the velocity, and then applying the estimation for what the motor is going to do. Minus that, so it's like positive 004 for the Tarsus. I would like to see now what this is going to be. Very small values. Good. Essentially, I'm kind of looking for the resulting estimation of this to approach 0, because it really should be 0 in this case. That is the target. I know that's the target. Okay. Won't worry about any of that. I'll just jump right ahead to here. So these were the estimations. This one stayed the same. This one changed because it also wants to move itself. So the difference is 003. A positive 003. And what was it before? Who knows? It's going to lie to me. The previous estimation was negative 007. Now it looks like the estimation to be positive. Okay, it's actually still negative. I can't do math. 02023. Oh, this is parent and that's part. Okay, I was actually subtracting the wrong way. So yeah, negative 003. Okay, so that's good. It wasn't enough. We still have some leftover stuff. So from negative 007 to negative 003. So that's good. That has converged down to what I know it should be, which is not converge. It's getting closer to 0. Now I want to see if this has changed. So it's currently negative 0002. Hopefully this drops. It didn't really seem to change. 3 zeros a 203. 3 zeros a 206. So it got a little bit worse. The velocity between the two joints decreased, but the rotation error is still there. And it got a little bit worse. Very slightly. It didn't explode, but it got a little bit worse. Okay, so now what's it going to try to do? Presently, this one's running 004. That's the angle. This one should probably barely change. This one should barely change. Because this value is barely changing. But this one should be a bit better. Still be positive, but now not so positive. Okay, yep. So it increased by like 50%. Or, well, the value, yeah, this total value is going to increase by 50%. From 004 to 006. Slightly more than 50%. Okay. Again, hopefully I still am recalculating. Yeah, okay. 0. Good. Yep, 0. Okay, good. Good. Step out. And then I want to just Run this again. Continue. Right, wrong place. Take this off. Continue. Now we're back on this joint. Jump down here. Still small values. And I think that first number used to be a 5. It used to start with a 5, and now it starts with a 4. So that's good. And I think I probably meant to look at velocity between the two, but I guess I forgot. Oh well. Okay. They're getting closer. Still not there, but closer. 3 zeros and a 3. This is presently 2 zeros and a 2. That's really good. Okay. So these are these are converging really, really well. And then hopefully angle is getting better and approaching 0. Rotation error is currently 3 zeros and a 2. It's getting worse still. It's actually still just getting worse. But it is by a very small amount. A very small amount. And I stepped over that, and I did not want to step over that. Okay. Showing it, yep. 008. So it was 4, and it went to 6.9, and now it's at 8.6. So it increased by 20%. Yeah, okay. Would really like to see this. Um, 208. I'll step through this one more time just to see the result of that. 208. Interesting. The number's definitely going down. It was a 4.9 and now it's a 4.8. I don't know about the other numbers. I haven't really been looking at those. But everything approaching 0. I guess go look at this to see. Very small values. Okay, good. So this is an interesting thing. So they flipped now. Now it's slightly positive velocity. Right. 0013. And it was previously negative 3003. Technically, that is this is my desired velocity as well. So it is approaching it. Is that the expectation that I approach it? Well, I mean, I guess it's more that I'm trying to correct for that problem, which running through this a bunch of times, then I can see, all right, so in order to get the real velocity, I need to be a lot higher than that. Right? That's what's... Because I do reset it every time. It says, here's your velocity, and here's what's actually happening. This thing is that I want to see is the angle change. It's growing still. But I mean, I guess the good thing is that if this is the estimation for what the angle is going to change by, then it's like it needs to have kind of a different velocity. Because I think the IK angle is really low. It's like an order of magnitude lower than the error I expect. Present velocity 86. Step in. Zero zero 013. 0011. Okay, so I've actually overshot it. So this is a negative. Or not. Huh? This should absolutely have been a negative. A negative result. This absolutely should have been a negative result. Why is it positive? I suppose it's because the input is to start with this value, and then it subtracts the error, so it starts at 0. And then it's... No, why did that happen? Yeah, it's on this mode. Yeah. Why did that happen? Because it would have started by putting... And then it would add that term. And then it would add that term. Okay. That doesn't... I don't know. That just doesn't make sense to me. I mean, I guess it might be that low pass filter doing this. Because the start is 0 will initially be the error, which is this value. Or not the error. The initial value will be velocity. So 001317. And then it adds this error. And then it does the low pass thing and then adds this term. Which is just really odd that it says that. It wants to add. It wants to add. Do I not understand it? Maybe I don't understand it. Why did it not approach? It should be approaching the target value. Because if the output of this is like the new output or whatever. But no, that doesn't make sense. This should be... That is just strange. Why? Why did that happen? Yeah. Yeah, okay. So it is telling it to go further away, though. Why? That is so strange. That is really strange. The set point of the measure and the output is a change that I should apply to the measure. So this is a change. It's always it. So if I give two velocities, it gives me an acceleration. If I give two positions, it gives me a velocity. Right? So I had to go backwards. Very strange. I will attempt to not think about it too much. That is really weird. Okay, well. It's still a smaller change overall. Continue. I think this is probably the fourth one. Yes, this is the last one. I guess I'll jump to here. Looks about the same as it did last time. All right. So present joint velocity is 002. Sorry, is 009. Okay. Do we think the angle is changing now? To 1-1. Still continues to get worse. Well, I mean, I guess that just is the same number now. What is that? 3 zeros and a 2 1. 100th of a degree. It's probably fine, honestly. Okay, so I want to see this definitely flip now. This should definitely flip, and I'm gonna check. Check that the loading is correct too. That I'm not back to that or something weird happening with the controller. Because that doesn't make sense. Okay, so I'm gonna click to look at this first. So we're going to load to zeros, and then we're going to turn on memory set. Load zeros and turn on memory set. Memory set's on, all zeros. Okay. So I got to step into this to make sure. So memory says on, so we set that to input. There's a 0, there's a 1. I shift memory. I set that. This says the error is that value. So I'm going to take this, add, subtract that. Well, that's a 0. Yes, we're going to be adding this negative value. That is just, why? Why? Do I just have a mistake? I wonder if I have a mistake with this. Because this one, the output is the error. But here, something just seems wrong about it, right? Because that's just like, I mean, no, I feel like that's just wrong then, isn't it? How could that be right? It seems like this one is... Oh, I don't know. When it's below it, it approaches it. I mean, I guess that's just how this one works, isn't it? It will go over and then take a while to adjust or something. And I suppose that's, I don't know. I mean, I guess maybe I just need to have, maybe I should have it be higher, right? Higher than 1. Like it should be at least 2, right? Because it basically can't recover until the error is twice um the input. It's strange. It's strange that because this is like a full reset. This is like starting from fresh. And that's very strange. Starting fresh, it wants to increase the error. I feel like that's just not right. And it's one-sided. If this must be, I mean, this must be wrong. This must be wrong. I can't believe that's correct. This should be outputting a negative value. Absolutely. So is the issue the input? Small derivatives. Well, I already knew that. And I think my solution was to cut derivatives entirely. Well, not cut derivatives, cut delta from the derivative. Changing the division to multiplication is likely to yield the intended result. I mean, I guess I just use one. Division by 1, multiplication by 1, whatever. I ignore delta on the derivative. Because it's going to be fixed, is the weird thing. Why would you multiply by 1,000? I don't know, that just seems strange. I mean, it might even be just to drop delta entirely. It might just be wrong to use delta. Because, like, what does reasonable scale mean? Is delta supposed to be a large value? Yeah. Reasonable scale, like what? Like half a second? Quarter second? What should it be? Um, yeah, I don't know. I feel like I really gotta disagree with this. This is just wrong. It's going to sit above the value and lower into it. And I mean above as in like the positive. If it's a negative value, well, you know, here's the negative value, here's where we are. We'll do like this. Right? I mean, this is what I'm seeing. If it's a positive value, we're going to shoot up over it and then stay over it, apparently, because that's what I'm seeing. I don't know. That's really bad, though. That doesn't make any sense. I should not be continuing to accelerate, even a slight amount. Because like I said, this is essentially starting from fresh. It says the very first step that it wants to take is to make the error worse. Should it instead be the current error? Or what? Like, how could that be fixed? Because this should absolutely be outputting at just a purely negative value. It's just so strange. Because the way that it's reading to me now is that it's reading like... Is it wrong? It feels incorrect. Feels like this must be incorrect. Because that doesn't make any sense. I think at a base level it shouldn't be increasing the error. Like this is saying, oh, we've been running for a little while, but this is like... I'm at 0.2, I want to be at 0.1. Okay, at 0.1. That doesn't make any sense. It's gotta be wrong. Previous value. Wait, think about the flipped signs then. Target minus measure. I mean, that part's not wrong. A0 is kp plus ki times dt. So I subtract a little bit more than the error. So say I'm at -2 and I want to be at -1. I would expect something to be positive. So -2 plus target minus input, -1 minus -2, 1 plus 2, -1 plus 2 plus 1. Okay, so in this case, I end up reaching exactly. Let's see, the error is, or let's say the target is -5. Target is -4, input is -5. The error would be +1. So let's say 5 plus -4 minus -5, -4 plus 5, 1. I end up with -5. I want to be a -4, so I output -4. Is it just that it has that the first run is gonna be like that? Is that it? Am I actually outputting something different that I think I am? Does using this actually result in a different sort of output? So I don't know what kind of simulation this is, right? But this doesn't make any sense to me. The output is always... Okay, well, I don't know what 1 and 0 is. What's 0 to 1 over here, and what's -10 to 10? Filter. Is the output the target? Because if the output is the target, then it makes sense. A new value for the error. What happened to this text? That is crazy looking text. It is the new output. UN is equal to even reading this, UN equals UN minus 1. That the right output. Which yeah, I mean, yeah. The current value of the actuator. Wait, is it always like this? So the output I get is actually a new target. It's not a change. So I can essentially think of this as being I mean, yeah, like a new angle, right? So then I say, all right, this is the target angle that I should reach. And then I compute the velocity from that angle. And this would be new velocity. Well, I mean, I guess I can say that this is like taking velocity and getting an output for a new velocity. It's like this minus velocity. So actually, I guess in this case, it could just be this. Right. Okay. Does this even make sense? 0, 0, 2. Well, I guess it should be this times delta. 0, 0, 1. 0, 0, 0, 2. Okay, so I feel like that doesn't make sense then. This is too much. Very obviously too much. Yeah. Change in angle. Hey, Kemuth. Good day to you. You too. Okay. It got even worse. What? What was the result? What's your game about? You have guns and you're shooting robots. That's what the game is about. Okay, so what is this? I guess this value might be extreme. It is 5. Maybe that's just extreme. Can I modify in real time? Looks like it won't modify. Then I'll change it. It's called Crawlerbot? No. That's what I'm working on. That's the thing that I'm doing. I don't have a name for it. Not really. Right, the error is just the same value. Right? Same value. I mean, because in this case, the output is the error. I don't understand. Why would it... Okay. How about this? I think just depending on what the type is, changes how it returns the output. So like here, the output should be This is the new output, and this is the original input, right? Same thing here. This minus the input. Because I think in these two cases, it is outputting what the next output should be, not a change to the output. This one outputs directly just the error. It's always the error. So this one is a change. I think that's what this is. It seems like that's how it's running. So this one, still the same. Target velocity is a reasonable value. Yes, the error response, right? Is that really what it should have been, though? Yeah, because it corrects a little bit more than it should. Yeah, okay. It's a little bit of an overcorrection. And then this one. My velocity is that. It's my target. It should be some positive value between those two. Okay. That's a very positive value. I don't get it. I don't get it. Why would its output typically be to make the error worse? That seems like the only thing it can do. Is it will make the error worse. If they're very far apart, it's going to reduce it, but once it's close, it's going to make it worse. And then it will equalize at a worse value. Like double the error or whatever. Because that's way too much. That doesn't make sense. Okay. I think I'm going to wrap it up. I'm like an hour past now. So I don't get this. This really doesn't make sense. Maybe I should just run like run a script. I just literally run the controller with some input values and see what happens over time. And let it do like I don't know, let it control like the height of something. Because I just don't believe it. I don't believe this. Good luck. Yeah, I need it. Because looking at how, even just looking at this, like I'm assuming, I would really hope that this is the code that is creating whatever this display is. Where they took the screenshot from whoever wrote this, because they need a citation apparently for 2 years now. And it's possible that they just have a mistake and all of this is wrong. Because even looking here, this doesn't make sense to me, right? The measure is over it, right? And the output is not, like, I don't know what output is like, what scale is the output on? Is the output the 0 to 1 scale, or is the output the -10 to +10 scale? I don't know. Which one is using this? So, or is this one the output and these are the measure and set points? Is 0 to 1? Because what doesn't make sense here is that we're over it and our output says to stay positive. Like this should taper off and then like flatline here when this crosses. Or once this crosses, it should be in the negatives. So I really don't understand. I don't know. Should I like follow this mess? And I don't know, just like looking at this feels like this is not the same thing. I don't believe this is the same thing. Supposedly, this is that, and it does not look like that at all. It looks like it's just straight up not that at all. Because that literally just shows the operations too. Take the reference up, subtract the measured. Take 1 over the value, and that gets you the error. I don't even know. What is that? 1 over E of n? No clue. I think is what I should do. I think I should just run a simulation with some inputs and see what's happening. Because I think something is wrong. This block diagram is not followable. I don't know. Like, you have to make too many assumptions about what's going on. Take 1 over the value, and that is En. Then what is this? I take 1 over the value again, and I get, that's En minus 1. I think this is actually just a stupid example because they set derivative to 0. So they say, oh yeah, we multiply that by 0. What are you talking about? That's it for today. Thanks for watching. I'll be back tomorrow. Goodbye. Hang on. Will not be back tomorrow, actually. I will not be here tomorrow. I'll be here the day after. All right. Goodbye.